Okay, so inshallah today I want to do two things. One is to show you um, a midterm solution for the girls section, which is quite similar to yours. But more importantly, to show you some new features that I have added to this solution that might be useful for your project, and also to highlight and explain a couple of important things to keep them in mind and to use them in your project as you move forward. Then I will be spending hopefully most of the session on Kotlin coroutines, which is a new topic, very exciting topic that I will explain hopefully after 10-15 minutes. All right, so what I will do first, let me run this app and I'll show you what it does, and then I will explain it super quickly, and then we move to today's topic. So while waiting, let me just try to run it directly from here. Okay. Okay, here it is. All right. Here's my shopping list, and okay. Here's my shopping list. What I can do, I can delete and undo. I can also add. For example, I can add here cherries, 10, and add. If I add something that already exists, the quantity will be updated. So if I do here apple, another 5, you watch this. This will become 10. When I am done, I can cancel. If I try to add without selecting an item or putting the quantity, I get an error, and I can go and fix it. Try to add again, show me the quantities required. Put 9 here, add, and when I'm done, I can cancel. Okay, so let me show you quickly how this is done. First, the model. Here is the model. Item, it has a name and quantities, super simple, just the name of the product and the quantity. The repository, it basically reads from the assets to initialize this list. When we first load the app, we have some items in the list. These items, I read them from shoppinglist.json. Now, to initialize this list, we used to do, if you remember, we used to do something like function init, let's say init list, and then we write the code in here to initialize. This is not very elegant. I find a much better way on Kotlin, very nice way. What I can do is I can say I want to initialize this list the first time somebody reads it. I don't want to initialize it if nobody accesses it. I don't go initialize it. So this property is basically called the lazy property. It will be only initialized the first time somebody accesses this variable. So how do I do this? I'll just say by lazy. Lazy is a function that takes a lambda as a parameter, as an argument. It takes a lambda, and this lambda, all it does, exactly the code that was in init. So instead of having this init and I have to call it before I can access this variable, I don't need to do this. I basically pass the initialization in this lazy to this lazy function. In our case, it reads from JSON and converts JSON to a list of objects, and that's it. First time somebody reads this, this will be executed. Second time, this will not be executed, and whatever value is already stored will be returned. So that's basically the idea of lazy property. Very simple, very elegant. Okay, now second thing I want to show you is So in this application, I basically have two fragments. One is the main, one is the shopping list, and the other fragment is add item. So two fragments only, shopping list and add item. That's it. Now, for the shopping list, nothing really fancy about it. Straightforward. For the add item, also straightforward, except if you notice here, the add item is not a full fragment. It is a dialog that gets pop up on top of my screen, and my main fragment is still visible, and this fragment comes on top of it as a dialog box. How do I do this? It turned out to be very simple. When I try to do it, very simple to do. So add fragment, all I need to do, instead of extending fragment, I extend dialog fragment. That's all. That's all the change there is. And then on create view, I inflate the XML and pass it to the view. So the view will load this XML here, this XML layout. And the rest is exactly the same. Now, if somebody clicks cancel, or if they just click anywhere other than the dialog will close. And how is it done? So basically, when somebody clicks cancel, then we just call dismiss. And dismiss will simply close the dialog. Now for add, when somebody clicks add, when somebody goes ahead and clicks add, I do a bit of validation here, small validation. I say, if the selected item is not selected, nothing is selected, I'll just go ahead and show an error and put the focus on this so the user can quickly go there and pick up. Now you see the focus, the cursor is not on quantity yet. So if I put add, it will show an error because it is empty. I show an error, and also set the focus to that particular edit text box. So the user can simply type the value and go ahead and add the item. Okay, now for adding, super simple. I create an item and I go to my view model and add the item. I will explain what is in this view model shortly. And then once the item is added, I clear the list box, I clear the spinner, and I clear the text box so the user can enter another item. So you see here, for example, I choose here peach 10 add. Peach is added here, and then it's clear, the form is clear, so I can add more if I wish. I can say strawberries 8 add, gets added and cleared. So I can do multiple adds on the same screen. So this is a nice example to show you how to do it. Okay, now for the delete, you're already familiar with it. So when this one is clicked, it gets deleted, but you have the ability to undo it if you wish. If you undo, it gets added again. If you delete and undo, it gets added again. So I hope it's clear. So let me show you how the delete is done. So here is my shopping list fragment. So when the item is deleted, all I do, I basically go to my view model and delete the item, and then use snack bar to offer the user the ability to undo. If they decide to undo, I will take the item and add it again to the view model. Now, introducing the view model really simplifies this application, made this application much more elegant, and this is the proper way of doing it. I'll be pushing this shortly after the lecture. Please go through it and try to adopt this style in your project and in any implementation moving forward. So let me show you this view model, how it looks like. So view model is basically a class that implements Android ViewModel. We can make it just implement ViewModel, but in this case I made it implement Android ViewModel to be able to access the app context. Why do I need this app context? Because we need the app context to be able to read this file here from the assets folder. So this file from the assets folder, you can only read it if you have a context. A context, it could be an activity, it could be a fragment, or it could be the whole application context. So to get access to the application context, all you need to do, your view model need to implement or extend Android view model, and this gives you free access to the app context. Okay, so let me show you another interesting thing here. I have basically shopping lists, which is supposed to be just a list of items. I could make it simple as this, a list of items. It could be as simple as this. Of course, I need to initialize it. Let's say list of, and I can start initializing it. So this is a list, but I want this list to really not be just an ordinary list. I want this list to be observable, which means if it changes, I need to notify the UI so the UI can update itself. So the UI, in this case the fragment, can observe this list and change the interface accordingly. You see here, when I add something, it is immediately visible. Immediately. You see here, take a look, this is 16, I add another 4. Immediately the change is visible. If I add a new item, immediately visible. Let me add something that doesn't exist. Pair 10, add, immediately visible here. So as I add more items, I just need to add them to this shopping list and the view will be automatically updated. So that's why instead of making it just a simple list item, what I will make it a live data list item. I need to make it this way. Okay. Now, if I want to initialize this live data, I want to initialize it with the data coming from this shopping list here. I want to read this. I initialize, when the app loads, I want to initialize this live data. So to initialize it, all I need to do, I use this object here. It comes from Android. It comes it comes with it comes with this library, the live data extensions that we added before. So this function here comes with this life cycle view model and life cycle live data. It comes from these packages. So what this live data allows me to do, all I'm doing, I go to my shopping repository.get list. I get the list from the file, and then I'll emit that list. That's it. This line here allows me to initialize my shopping list as a live data list item. Now, this live data will be changed. You see here, I can add to it, I can remove from it. So that's why I add one more thing here. I'll say as mutable live data. So I want you to go ahead. Let me do it in a short. So what I'm doing here, I'll go for items. I'll go to the repository. I'll go to the repository and get the shopping list. I read the shopping list. And remember, this is a lazy property. First time I read it, first time I get it, this will be executed. And I will get my I'll get my shopping items. Then I put the shopping items in a live data. This is how I do it. I use a live data function and I read from the repository and emit as a live data. Why I am doing this as mutable live data? Because I want to change it later on. That's why. But I only want to change it from inside the view model. From outside, nobody should be able to change it. So that's why this is a very common technique. I make this mutable live data as private and then expose it as a live data, which means from outside I can watch it, I can read from it, but I cannot read it. Sorry, I cannot change it from outside. Okay. All right, so I hope it's clear. Now let me show you the add. So for add, when you see here, when I say add, there are two scenarios. If the item already exists, let's say banana, and I put 5, watch this. Instead of 20, it will become 25. And if it's new, then it will be added. Let's say maybe grapes, 10. Because it doesn't exist in the list, it is added. Can you see it here? It's added. So this is the logic to do it. So what I do, I go and access the value of my live data. Because this could be null, that's why I'm doing this. Unfortunately, they put it as null. But anyway, it's not a big deal. I ask when if it is not null, then I will enter and do this work here. So what I do, I first find if the item already exists. Okay, if the item already exists, then find at will be greater than or equal 0. If the item does not exist, find at will be equal to -1. So if the item already exists, all I do, I get the quantity and increment it. I get the quantity and add the new. Sorry, I just need to mute Abdullah, he's annoying us. Okay, just a second. Mute, خلاص. Okay. Yes, here I am. All right, so if it exists, the quantity that I ordered, let's say, as I showed you, apple, a banana, I put 5, the quantity will be increased. So this is exactly what I'm doing here. And then the modified list, I need to assign it back to value. This is very important, this and needed to notify the observers. Now, if the item it doesn't exist, then I add it to the list and take the new list and assign it to value. This is an elegant way of adding an item to a list. Very impressive. You just go to the list and add plus item. This is the same as add. Okay, this is for add and this is for delete. For delete, just go to it minus. Minus means remove this item from the list. Allahu Akbar. I hope it's clear. Now, and then whenever the user is interacting with the view, with the shopping list, they can add, which also include update, and they can also delete. Okay. Now in my view, which is in the list fragments, all I am doing is this. I'm going to my shopping list and observing it. Whenever it changes, I get the new list and pass it to the adapter. And the adapter, you can see here, it receives the new list and notify data set change. So for the recycler view to refresh itself. Very elegant. This is the best way of implementing this. And this really shows the power of ViewModel and live data. So I have ViewModel that holds my data and implements the add and update and delete. And in my fragment, all I'm doing, observing the list and letting the adapter know that there is a new updated list. And that's it. This takes care of the whole magic. So as I delete here, it gets reflected immediately on the list. As I add, it gets reflected immediately on the list. Yeah, so I hope it's clear. So inshallah, I'll be posting this, and please take a close look at it and try to follow this pattern. And also, if you need in your project, if you need a dialog box, now you know how to do it. All you need to do, instead of implementing fragment, you will implement dialog fragment or extend dialog fragment, and that's it. The rest is the same. And if you want to close the dialog, all you need to do is call dismiss. Okay, any question on this? Okay, if not, I will move on. This is with quick review and a nice simple example demonstrating view model and live data. So please take advantage of it and use it in your project. It will really simplify your work significantly. Okay, now let me now switch the focus to something interesting. Here it is. So what I have here, let me just close everything and let me run this small app. So this app basically has two buttons. One does some lightweight work, simple work, like incrementing a value. Another button does very heavy work. And I will show you what happens. Here it is. This is doing simple work. No problem. It works immediately. I get the answer. Now this one, Fibonacci, I will explain this Fibonacci function. It's very well known mathematical sequence. It can be quite heavy. If you want to generate a large sequence, it can take a long time. It can take it might be a long running task. So let me try it. I click here. Once I click there, you see now my UI is no longer responsive. My UI is blocked, waiting for this Fibonacci to finish. Even Android has detected this. Say Coroutine Basics, this app is not responding. Do you want me to close it or wait? They wait. It will come back, hopefully. Still going. Because this Fibonacci is very heavy, so it's blocking my UI. Is this something good? Do you think my users will be happy with this? Blocking their UI and getting them confused and pulling their hair and frustrated? This is what we want to avoid as developers. We never want to put our users on this situation where they interact with the UI and the UI is not responsive. Are you following what's going on here? I click here, khalas, my UI is not responsive. This is not good. But at the same time, I need this work to be done. So what is the solution? First of all, are you following with me, or I am just talking to myself? Do you see the problem?
Yes, doctor, yes.
Do you see the problem? Do you think this is something that the users will accept?
No, of course.
Of course they will not accept this. So we have a problem and we need to find solution to it. We are happy with our application is running on thread. So basically a thread is, let me show you. In here, when you have an app in your hard disk and you, let's say, double click on it or touch it, it gets loaded from hard disk to memory. And the CPU will create a process to run your app. So in here on Windows, for example, here are the processes that are running. This is process. This is another process, and so on. Many processes are running. Some of them have multiple processes, and some of them one process. And inside that process, you could have multiple threads. And basically, an app will run on one process, and a process will have at least one thread. When you run an Android app, it's running on one thread, and that thread is called the UI thread. Now, that UI thread, you should never use it to run long-running operations or long-running computation. You should never use it to go to the web to fetch some data from the web, because that might take a long time. And what will happen if you use the UI thread to do long-running operations? What happened? Anyone? What happened when you...
The UI will freeze.
The UI will freeze. Thank you very much. The UI will block. Do you think your users will be happy when your UI blocks? Of course, they are not happy. Okay, so basically, this is the users are happy when the app is responsive. But if we try to get some data from the web, or if we try to do some long-running operation, our thread will be blocked. Our UI becomes not responsive. This is a problem. How do we solve this problem? Any ideas?
We create a new thread specifically for this process.
Okay, thank you very much. For anything long running, we don't run it on the main thread, we run it on a separate thread. And this is exactly what we will be going to do. Here it is. So what I will do here, instead of running my Fibonacci function inside here, inside the main thread, I'll go ahead and create a new thread. This is how I create new threads, similar to Java. And then I'll say, go ahead now and enjoy running this Fibonacci sequence for 1 million elements, or return to me 1 million Fibonacci sequence with 1 million elements. And then I'll go ahead and say thread.start. Let us run this now. And let's see how will this help or not. Is my UI responsive? Let me run now the long running task. Fibonacci is started. My UI is still responsive. No problem. Let me just close. Sometimes I have a problem when I run it many times. Let me just rerun it, just for the debugger to give me some interesting data in there. So let me show you. Let me run it again. So now I have two threads, one for the main, one for the UI, and one for running this long-running computation. Okay, here is my UI, and here is the long-running. And basically, this is still going nicely, although this is going, this is, I'm not sure why I'm not getting debugging. Okay, let me just try it one more time. Let me close this as well. Okay, let me just run Android Studio again. Just I will explore why the debugger sometimes does not show the values. Okay, so to summarize, when you have a long-running computation, then don't do it on the main thread. Put it in a separate thread to keep your UI responsive. And okay, all right, let me open my Okay, good. Now, okay, now it's going nicely. This is just from that Fibonacci. It's just the debugger. Anyway, I clear it. Let me go to info. Hopefully this time it will work. Let me run. Okay, and the way you create a thread, you just go ahead, create a new instance and pass to it the work you want to do, and then start it. Okay, almost there. And by the way, Fibonacci is a sequence where the first element is always 0, second element is always 1, and the the value is basically the sum of the previous two values. So for example, 5 is the sum of the previous two values. 21 is the sum of the previous two values. And this is the Fibonacci series. In general, Fn is Fn minus 1 plus Fn minus 2. And F0 is 0, F1 is 1. That's basically what Fibonacci is. But it could be time consuming to generate a large sequence, as I demonstrated. Okay, so hopefully here's my UI. Okay, nice Fibonacci. Okay, good. Now, you see here, still responsive. Why? Because I have two threads. One for the main thread and one for this long-running task. So this is a value of multi-threading. So multi-threading is a really needed for Android. The reason why we need it, because in Android, as we will see from now on, as you will see moving forward, we do a lot of network calls to get data from the web or to push data to the web. Some applications, as you know, could be working offline. So we do some changes offline. We don't have internet, and then when there is connection comes back, we push the changes back to the server. We also have we can read and write from database on an Android app. We sometimes do some complex computation, so we need to use multi-threading. But threads are not the optimal solution. They are very costly also. When you create a thread, every thread will consume 1 megabyte of memory. And also some threads are special, such as the UI thread. If you do anything heavy on the UI thread, you will block it. So threads are okay. You can use them, of course, but there is a much more elegant and more powerful way that Kotlin has introduced, which is called coroutines. So coroutines are lightweight threads, and it allows us to we can suspend them and we can resume them. We can also cancel them. I will explain all of this shortly. So you can think of coroutines. Kotlin did not invent these coroutines. They were invented in the 1960s. But coroutines implemented those ideas in a very elegant way. So what you can think of coroutines versus threads, if you look at construction sites, in a construction sites, you will have multiple workers. So you can consider each construction site as a thread, and the workers in each thread are coroutines. So basically, in one thread, we can use multiple coroutines. We can run multiple coroutines. So that's basically the power of coroutines. So coroutines are much lighter weight than threads. Okay, now we can the advantage of them, we can suspend them and resume them, we can cancel them, and we can run them in a way that is life cycle aware. Let me explain each of these features one by one. through some simple examples. Okay. So what I have here, all right, no problem. Yep. Okay. So what I have here, this is not within Android. This is just a normal kind of console application. And what I have is this is how I create a coroutine. This is one way of creating a coroutine. So what I'm doing here, I'm going and saying, I want to create a coroutine, and I want this coroutine to run on the default dispatcher. So there are a lot of things going on here. I will explain them, but don't worry too much about it. So to start a coroutine, what I'll be doing, just a second. To start a coroutine, I basically, in this scenario, as an example, I go ahead and don't worry about this. Let me just remove this for now. Too many things going on. Yes. Okay. To start a coroutine, which is basically as if we are creating a new thread, I can use global scope.launch. Or let me put it another way. Let me go through this example itself. So instead of using a thread, I will use a coroutine instead. And one way to launch the coroutine, I can say global scope dot launch. And inside here, I'll put my code. This is how I run I want to run this code inside a coroutine. So this is how I started. I need to have some kind of coroutine builder. We call this a coroutine builder. And I'll ask it, please go ahead and launch this in a separate thread, in a separate coroutine. Okay. So let me run this first, and I will explain it. Let me run this. It's just running. So it's exactly the same. I'm not doing this on the main thread. I am launching this in a coroutine. Coroutine is similar concept as a thread, but it's much more lightweight. It doesn't use as many resources as the thread, and it gives us some very powerful advantages that I will explain shortly. Okay, so here it is. Here's my increment working, and here is my Fibonacci also running, and my UI is still responsive. Unfortunately, this is not showing anything. I need to restart it, terminate, and let me just rerun it again. I will figure out why the log does not show the values sometimes. I'll figure it out, but for now, this is the workaround, is to restart Android Studio. Hopefully this time it will show up. Okay, run. All right. So exactly the same. Instead of creating a thread, I'm creating a coroutine and running this inside the coroutine. Let me just go to the debug so I can show you. Let me clear this. And let me still didn't run. Let me try it one more time. Okay. Come on, go. Okay, so it's going. Yep. So it's taking its time. So in here, by default, this will run on a default thread. So an Android app has multiple threads already running. I can choose which thread this coroutine can run at. So let me see if this works. Okay, good. This is increment is working. And this is my Fibonacci. You see here, I have two threads, the main thread, and then I have a dispatcher thread, a default dispatcher. Can you see here? There is a thread called default dispatcher, and my coroutine is running on this default dispatcher. Okay. So let me just comment. Okay, I realize now. Let me just comment this so it does not put too much stuff on the too many things in there. So this is the last time I restart this guy. I know now the problem. Sorry for this multiple restarts. By next session, I will figure out a better way. Come on, go, go, go. Yep. Okay, good. All right. So now let me also comment this. So I'll just leave this one and this one. So this will show me the main thread, and this will show me the thread where this coroutine is running. So let me run my app. Here's my app. Now in here, by default, this coroutine will run on a thread called default thread, but I can choose a different thread. So for example, all I do here, I say dispatchers. Dot. These are the threads that come with Android app. So there is a default thread. This is usually, you can use this for heavy computation. The IO thread, this is for reading and writing from a network. And there is a main thread. This is the UI thread. And you can create your own thread as well. So by default, if I don't specify a particular thread, it will run on the default dispatch, on the default thread. So let me show you. If I come here, let me clear this. Here's my increment. Here's my Fibonacci. You can see here my UI is still responsive. And here, the main is running on this thread called main, and the coroutine is running on a thread called dispatcher. I can change this. I don't want to run in the dispatcher thread, sorry, on the default thread. I want to run this on the UI thread, on the IO thread. So remember, multiple coroutines can run on the same thread. Multiple coroutines can run on the same thread. So you choose which thread you want to run this coroutine. So let me rerun this. And hopefully now when I run, it should say here IO thread, IO dispatcher. Dispatcher and thread is the same. These are built-in threads that are already there. When you run your app, you can access these threads and use them to launch your coroutines. So here is my increment working, here is my Fibonacci, and you can see here it's still doing it in the dispatcher, still doing it in the default. Okay, let me rerun this. Supposed to use the IO thread. I ask it to use the IO thread. Yeah, it's still using the IO, still using this. I'm not sure why. Anyway, we're supposed to be able to, let me try to do main. Or maybe this is not refreshed. Yes, can you see it here? It's both of them running on the main, but it's still responsive. Why is it still responsive? Anybody can explain? Although I'm running this coroutine in the main thread, the app is still responsive. Any idea why?
Maybe because the coroutine do the job.
No, basically the coroutine does not block the thread. So although this is running inside the thread, it's not taking the whole thread and blocking it. So so the idea here, so if we have a construction site and we have workers are basically the coroutines. If one worker is very busy doing some work, it's not blocking others. Others are also can do other work. So coroutines they are very lightweight and they don't block the thread. Okay, so why this is important? Let me just explain it one more time. Why this is important. This is the last thing I will explain and let you go. If I'm launching this app here, and I'm running this, and then I'm running this heavy computation on a coroutine. This heavy computation is running on this thread called default dispatcher. Now, the problem here from this coroutine, let me try to go to score text view dot text equals score plus plus. Dot toString. Okay, let me try to run this. You see here my app crashed. Why? Anybody can tell me why? Only the original main thread can touch the views. So from the main thread, if you have a coroutine and this is running on separate thread, you cannot access the UI from another thread. And this is the same in here as well. Same in here. In this thread, you cannot access the user interface. So now with threads, there is no way you can access the user interface. If you try to do this, this will crash your app. Because this code is not running on the main thread. Only the main thread is allowed to change the UI. So how do we solve this? With thread, it's very, very hard to solve. This problem is very hard to solve. But with coroutines is much easier. All I do with context, and then I'll say dispatchers.io. I want you to run this. I want you to run this in the default thread, but I want you to run this in the, not in the IO, sorry, in the main. But I want you to switch and run this in the main thread. So another power of coroutines, I can change the thread where the functionality is being executed. Okay, so here, if I run this, this should be okay now. So this is another power of coroutines. I can switch from one thread to another. So similar to analogy to our construction sites, a worker could work on one construction site, but they can jump to another construction site and help them do some work and maybe come back to the original construction sites. So maybe there is a plumber. They can work on one construction site and jump to another construction site very easily. And this is the power of this. So if I go here, increment Fibonacci, I basically have two threads running. One is the main and one is the default dispatcher. But no problem, I can basically access the UI from this, no problem. I can access it from there directly. And this is another power of coroutines. I can switch from one thread to another. And here, if I do a log here, you will see that this will be running on the main thread. So this part is running on the default thread, not to block the UI, and this part is running on the main thread. Why are we running this on the main thread? What I'm highlighting here? Just to see if you are following.
Because we cannot change the UI from the...
Yes, thank you very much. If you want to access the UI, you have to switch to the main thread. How do we switch between threads? I just say with context, and I'll say, please go ahead and do this work in the main thread because I'm accessing some UI. Heavy stuff, keep it in the default thread. Okay, so here it is. So as I click this, you can see here, this is running updating UI. Okay, let me run it again. So updating UI will be on the main thread, this heavy computation on the default thread. And I can switch very easily from one thread to another. Believe me, to do this with the threads is very hard. With coroutines, super simple. I can jump from one thread to another very easily using this with context and specifying which thread I want to jump to. Always, if you are confused, always think of this similar analogy. Construction sites, coroutines are workers, and these workers, they could jump from one construction site to another or from one thread to another. Okay, so here it is. So here I am running on the main thread. The whole app is running on the main thread, and then the heavy computation on the default thread, and the UI updating on the main thread. I run this again. Same thing, as you can see. Let me just clear this. If I click this, so heavy computation on the default thread and UI update on the main thread. And that's basically the idea of coroutines. I can also cancel the coroutine. I can suspend them. I can run coroutines in parallel. We will see all of this, inshallah, next time. And I will also show you how to use coroutines to read and write data from the web using Web API. And later on, we'll also use coroutines to read and write data from a database. So this is very, very interesting topic, very important. And the reason why it is important is because in every app, we have network calls to read and write from data from the web. We have complex computation. We don't want to do it in the main thread. And we have database operations. We don't want to do them in the main thread. We use coroutines not to block the UI. And the coroutines are much lighter than threads. And we can easily switch from the background threads to the main thread if we want to update the UI. So these are the main messages I want to introduce, and inshallah next time I will explain this in much more details and give some more concrete examples. Okay, thank you very much, and inshallah I will see you next